part 2 of the theory of everything, unification theory. It's hard to describe, really. I mean, what are the odds of creating something fake that ends up covering viable explanations, let's just say? It's like even Einstein spent space. It doesn't work for things like magnetism. It can't be applied to other forces we interact with. And yet here this concept can be understood, because it can be understood that it moves through everything. Everything where a force is conveyed is going to be conveyed through this mechanism, these quanta, this energy. And that this is the only energy. It's the only source of movement is stuff moving, and you don't have that with a bent space. And I was thinking about the bent space thing too. They really don't accurately represent it, in that it's because of the inverse square rule. It's a very straight line of this curvature. They call it a curvature. Well, it's really not a curve. It's a pretty straight line, and so it's not even an accurate description. And the metaphor isn't even accurately drawn as a metaphor. Anyway, all right, colliding with technicalities. So now we're talking about gravity. So I guess I might as well zoom up to the image of the gravity, and I'll read. I would like to say the Earth is pushed into the sun and leave it at that. Oh, would I ever? So traditional theories of gravity are pull. And basically, before Einstein, they would just say, it just does. Okay, like magnets attract, it just does. And that was the answer. When Einstein gave you this mechanism, theoretically, some sort of bent stuff, that bends in completely unnatural ways. I mean, it has to be straight lines. Like somehow space has to be capable of making straight lines to create an inverse square convergence. A convergence consistent with what we know to be the truth. But it also creates all kinds of paradoxes, in that you can have an endless supply by just making the curve deeper and deeper and deeper, where I would argue that in reality there is a maximum, there is a vacuum, technically creatable theoretically, and that vacuum would give you a clear measurement of the absolute force. Anyway, and leave it at that. But the whole truth is a bit more complicated. A bit more complicated. Yes, the little bits will make it a little bit more complicated. In a kinetic particle pressure, in a field of kinetic particle pressure, direction is exchanged, not really imposed. So pushing implies an imposition, where what really takes place is acceleration. These things move, and by moving they absorb this speed of light stuff here, gets converted into something much slower and slower and slower, and it really doesn't get to this other thing unless it falls into it, actually. I mean, these arrows the Earth collects as acceleration as it's constantly going around. They just don't quite get to ever crash, because they end up getting used to change the directional vector of the Earth. The Earth's momentum is perverted, bent into a new direction. So anyway, and this arrow is essentially released as say the Earth's going this way, this arrow would be released as an equal but opposite reaction in the conversion of momentum, directional momentum. So it's all conservative, and that's the real beauty of this whole thing. Anyway, not really imposed, and the rate of exchange has circumstantial rules. So the rate of exchange is sort of a how it's all translated in the end. And so there's lots of the energy is, like I said, this speed of light ends up being converted into something less than the speed of light, but technically it doesn't. It only looks that way because it has a lot of interactions, and those interactions end up taking stuff that was going one way and making it disappear for a while this does its job. And so it basically moves every little speck inside of here. This ends up moving every single little speck to make it accelerate. Every little bit has to actually be moved, because it can't move on its own. Stuff going this way can't go forward, right? It just can't. The stuff's going this way. It can't go forward. Something has to make it go forward. It can't just have velocity and also go this way. You can sort of understand that a photon can't go one direction and then also go another direction at the same time. It can't. Alright. For example, in the case of the Earth being gravitationally pushed toward the Sun, it might be more accurately stated that the Earth and the Sun induce acceleration in each other. So the argument is that it's induction. It happens a little bit at a time through a feedback loop, and it gets up to a maximum state. Just like, say, the way magnetism induces electricity or current to flow. It doesn't do it automatically. It has to create a field and a flux, and that flux reaches its maximum, and then you can vibrate that flux to create energy, movement in some other direction, tangential to the field. So the field, the magnetism goes out this way, and the current will go this way, because they'll be in different dimensions. And that's how they're inducing the transmission, let's say, of energy, is through this idea of tangential dimensions. This dimension can affect this dimension, and this dimension can affect this dimension. That kind of thing. Alright, anyway, going to a level deeper, it could be said that the acceleration merely reflects acquisition of force arrows moving in the direction of the acceleration. So acceleration, as I'm stating, is these arrows go in. Most of them go right through, but a certain percentage, a certain number of them, will stay in here and do work. So they'll be caught up in spins and sort of spin this whole thing in this direction. Each little spin will be given a little more spin, and all those little spins will equal a roll, essentially, in the internal mechanism. They'll just kind of move this to this way. So it's acquiring essentially this arrow and getting rid of arrows that are going this way or this way. So if it has parts in it that are going this way and parts of it going up, those parts will be dispensed with and replaced by parts going this way. So the net effect is it gains an acceleration. Now the trick is the Earth has a velocity in this direction, and those two vectors will be converted. This acceleration plus this velocity will be combined as a single velocity, and that will be the new starting condition, so to speak. So it has to keep getting induced, re-induced, 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 because it keeps changing the directional vector. Alright, going a level deeper. Still deeper, it is understood that getting arrows will usually mean exchanging old arrows going in some direction for new arrows going in the new direction. So that's basically what I just said, is basically the dance this Earth is doing. It'll give away some of the dance steps, and it'll change those dance steps for this step, going stage left. Alright. It is here at the deepest level of the kinetics where the rules are applied, and the most important rule states that a directional arrow, element of force, can only really exchange direction with an element moving in a tangential direct dimension. So the head-on collision, like there's arrows inside this body, let's say they're going this way. Those interactions are nothing. This one goes right through that one goes right through that one. It doesn't turn out to be anything, because whatever polarization or frequency this arrow has, it goes right through. It takes it with it. When it hits something going tangential, something different happens. This arrow takes this arrow's direction, and this one retains its polarization and the frequency goes the way it was going. So frequency is, in a tangential collision, frequency is maintained, but polarization is exchanged. A subtle difference, I don't know if it really matters, but the point is just to understand that the point is the force arrows are really going to possess the matter. The matter will be converted into these. If enough of these go in, they will convert the entire body into arrows going that way, which would mean this mass would just be a bunch of light going that way. So if you convert all the arrows to this, this moves the speed of light, and this just becomes a bunch of photons. Okay. But yeah, this tangential thing is really important. So recognizing that these things do function in dimensions is really important. And so the stuff going back and forth is irrelevant to this force coming from this side. And the only stuff that really matters to this force is the stuff going this way or the stuff going this way. You know, left and right and up and down are the only dimensions, the tangential dimensions. So it's sort of a thing to kind of understand that in a three-dimensional world, from every one dimension, in any one vector, the half dimension of one of those one dimensions, everything else is a tangential dimension. The other two dimensions are tangential to your dimension. So left to right is tangential to up and down and forward and back. They're all tangential, 90-degree angles. They're not on a, again, it's 90-degree angles. I don't think I need to say more. Tangential. In more real-world words, in the kinetic universe, head-on collisions are the least meaningful accident, as all elements of identity pass through the interaction. So basically I'm just arguing that head-on collisions, wherever you were, if you were blue, polarized, and you had a frequency, blue and polarized, and frequency goes through, and the opposite goes past you. So you don't, there's just nothing happens. A head-on collision is as if nothing happened in the real physics. And I give an example here. If you were driving a blue car down the kinetic highway and you had a head-on collision with a red car, after the interaction your blue car continues in the direction it was going, as does the red. So the red car goes this way, the blue car goes this way, and it's as if you didn't even hit each other. Okay, that's just a rule. That's why it's in bold. Rule. On the other hand, if your blue car were to hit a red car moving left to right or up and down, so moving in one of the other tangential dimensions, this way or this way, after the interaction the red car would be going forward and the blue car would be going right or down. So when this comes into a tangential interaction, the tangential thing gets converted to this, and this goes out the tangential direction. So the way the other thing was going. So you're basically replacing. You're releasing the thing that's here, you release it, and you collect this. So if there's an orbit happening here, the orbit gains this arrow that's not consistent with the orbit, but it will be probabilistically okay. The orbit will be able to take this change that's going to cause the orbit to move sideways a bit at a time. Alright. Your car will be going forward, the blue car will be going right or down. This little difference, as they say, makes all the difference in understanding acceleration and velocity in the kinetic energy field. So when you're moving in this field, it's really important to understand that you can't move into the force, you can't have friction with the force, because if you move into the force, those become head-on collisions. You end up more force arrows to move you. Those more force arrows means they're less tangential arrows, and so you end up with less tangential arrows completely proportional to the extra number of arrows you're coming into this way. So you're just when you're shooting more arrows, you lose targets. So as your targets decrease, the number of arrows coming at you increases, and it ends up being the same probability that you'll actually hit a target. So if you sort of understand it that way, the faster I move into the field, yes, the more of these things I'm going to hit, but the less of these going sideways or forward and back, the less tangential elements that will exist because I have collected a bunch of these arrows. And as stated, the head-on collisions are net zero events. Really is so, wow. Yeah, it's just so interesting. Anyway, I think so. Alright, so it makes all the difference. So let's again try to describe the relationship between the sun and the earth. So in this thing, I obviously have a hard time getting to the sun and the earth because there's all this subtle movements and things happening to the earth and the sun before gravity can even take place. So let's describe again the relationship between the sun and the earth, but now from the perspective of the kinetic field dynamics. First, let's understand that the sun and the earth are made of the same stuff as the energetic field that surrounds them. You, the earth, the sun, all the matter is just made out of these quanta, these field elements. And technically, okay, you are probably just those elements in specific dimensional spins of polarization. And so there's a whole bunch of stuff spinning and you're just the one that's going this specific way, kind of a thing. I don't know how exactly to say that. I'll leave it at that for now. There's a bunch of stuff, and the stuff that makes you, makes us matter, is the fact that our stuff is labeled by polarization and frequency. These are really important things in making this reality something we can filter out of what exists. We can see it because we can filter it out, so to speak. Metaphorically speaking. Alright, first let's understand that the sun and earth are made of the same stuff. Let's apply the simple E equals mc squared definition of matter and understand it to be merely energy trapped in generally balanced multidimensional orbits. So matter equals mc squared. Matter is energy. It's the photons, the gravitons, the stuff, the little bits in these orbits, and these orbits are what give us substance. It gives us mass in every direction. And again, back to that argument, that's a secret of the orbit, is that it creates a generalized mass. And that can have, that's something that has the capacity to create things like frequency. It can release quantum arrows at specific frequencies because it has a spin or a rotation, and it can release them all and that rotation. Things like that. It's the machinery of a necessary, the creator of, let's say, polarization and frequency. It's made out of it and it creates it. Alright, so E equals mc, so it's all energy. The difference is the energy outside of me isn't in orbits, isn't polarized, doesn't have specific frequencies. The matter inside of me does. That's the only difference. Same quantum, this quanta orbits. Alright. Okay, let's understand that an orbit is effectively just movement in every direction within the dimension of the orbit over a period of time. So you can have a sphere, okay, where the orbit processes through all the dimensions, all three dimensions. Or you can have an orbit like a galaxy. You know, like a sun is a three-dimensional sphere of spinning goop, where a galaxy is a flat-dimensional spinning blob of goop. Okay. In the function over a period of time, every direction, Condensing these statements, matter can be understood to have an intrinsic balancing mechanism in the function of an orbit. So you can sort of understand the conservation nature of orbits. So much this way, so much this way, so much this way, so much this way. And if it ends up with an imbalance, it gets rid of the imbalance by moving through space. So it can essentially roll through space. It can have more arrows going this way, and they will just cause it to roll in that direction in a sense. It's not really rolling on a surface, but it's just technically it's being migrated by its extra potential in that direction, so it's essentially a way of getting back to balance. It's always going to go for this balance thing. That's like a rule. Balance be good. And so it'll be forced to find some way to compensate for the extra, and a roll will be the compensation. Alright, for an orbit to be durable, it must obey general conservation rules, and generally bits will move in one direction as much as they move in opposite direction over a period of time. So the argument that generally orbits, even if they're ellipses, they still move the same amount this way, this way, this way, this way. They're always a rectangle or a square. They always have this conservation built into them, and they essentially maintain that conservation even when they're imbalanced by moving. So if they move, they can stay rectangles, if you get me. They can't stay a rectangle if they allow the imbalance. Like say you have more direction going this way. If they allow that direction to not be compensated by a balancing movement, then obviously the orbit will be destroyed. This will keep going. This stuff going tangentially will not keep up, and the two things will be separated, and there will be no longer an orbit. So for the orbit to be maintained, imbalance has to be realized as directional spin, as rolling. Okay. And over a period of time, let's see, for an orbit to be durable, must move opposite direction over a period of time. Pushing this to a simpler concept, a bit of matter can be understood to be a substantially balanced quantity of energy that can, depending on integrity of its orbital structure, gain through acceleration a net imbalance in any or all of the three dimensions. So the acceleration is the extra arrows, and if the orbits are somewhat durable, they can be pushed to this limit. They can be obliged to start moving, and yes, but yeah, you can imagine that there has to be a certain amount of durability. You can't push on cotton balls. You know, a wheel made out of cotton balls might not be able to roll. You know, it needs to have a certain stiffness built into it, in the sense that it has to have a certain depth, so that you can break it a little bit by changing it, and a little bit of change won't destroy it. So it can't be fragile enough that a single change will cause the whole thing to fall apart. Yeah, I don't know if this is a necessary point, but it's just the idea has to be understood that there is a general migration towards balance, and that there's these mechanisms, these ways of accepting elements of imbalance that will be compensated by some other effect, and the effect will balance the imbalance. All right. In other words, if a bit of matter has more bits moving in one dimensional direction than the opposite dimensional direction, that is more forward arrows than backward arrows, I go forward, it will have a net velocity in the dimensional direction. So if I have more arrows, I'm going to have some sort of movement. Alright, so if I have just, let's say I have a zillion little arrows, I have just one more arrow going forward than back. Then it's one arrow slash 1/zillionth, which would be 1/zillionth of, let's say, the speed of light. You know, so I might move one tiny little fraction per day. You know, one needle on, you know, the thickness of a needle per day. I might move that much because it's just one tiny little extra, and it takes a long time for that tiny little extra to go through all of my little bits and make all of my little bits move. If you can sort of get it. The imbalance goes through everything eventually. Every little bit has to be pulled along when you have a velocity. Every single little dot inside of me. every pixel of this screen. If I want this screen to move, I can't just move one pixel. I have to move every single pixel. It has to be personally pushed along. That's the idea. And the net imbalance all dimensions. In other words, right, dimensional direction, it will have a net velocity in that dimension. I emphasize dimensional because it's important to clearly understand that the kinetic bits can only move in one dimension in one moment of time. These are kinetic bits. Again, the tangential, if I'm moving forward, the bits inside of me going this way or this way cannot move forward. They're going this way and this way and this way and this way. They will not go forward. They have to essentially be replaced by an arrow going forward and then put back going this way and this way again. And that sort of time dilation, if you get it. But that's the idea. They have to essentially be, somebody has to basically bring the tow truck and tow them to the new forward position. They have to be dragged there by having their identity seized and being replaced, and they have to be replaced by a forward arrow, someone going in the right direction, quite obviously. And then they can go back to being tangents again, and then they have to move forward again, and then they have to be tangent again. So they essentially lose their opacancy. They become sort of transparent because some moment of time they just don't exist for every second. So for every second when I'm moving forward, for every second of my movement, there's a tiny little bit of time where all the tangential bits really just don't exist. Anyway, technically. Getting this back to the sun and the earth, well, I try to, but I don't quite get there. Let's try again to accurately describe the process that is gravity. First, let's isolate this dissection from the unnecessary distractions of other planets and imagine the sun and the earth are the only players. So let's get everything out of the universe, get these two players, and let's see if we can talk about what happens between them. Better yet, let's view the sun in isolation without anything orbiting it. It can be stated as a confident known that the sun has some velocity in some dimensional directions relative to the rest of the material universe. So we have this starting position point where we're already in trouble, right? Because the sun, even by itself, we know the field is jiggling it a little bit, right? But we also know that it's part of a galaxy in the universe, and that galaxy might be part of a cluster. So there's some other movements that are taking place that we can just be relatively certain those movements really wouldn't be possible if the sun was stationary. If the sun was stationary, we can't really come up with any physics that would explain why all these other things are doing this bizarre thing where they're stationary with it in some sort of sideways manner. I mean, you can't even describe how hard it would be to describe exactly if the sun was stationary, how the rest of the universe could make any sense, because it really can't. So you kind of know the sun has to have some velocity built into it already. What the exact is, I'm arguing it has an exact velocity in an exact vector, because velocity is always reduced to one dimension. You can't have velocity durably for any length of time in more than one direction. It always has to be converted into one direction. So if you have velocities in two dimensions, those two dimensions will reorient your gyroscope, so to speak, and now you'll have a forward dimension where all your velocity will be, and the left, right, and up, down will be bent, like a gyroscope will just be bent to that new directional vector. So it'll just change the orientation of the x-axis, so to speak. The x-axis will always be dragged to your net velocity. The addition of all your velocities will be your net velocity. Anyway. Okay, Barry Ellis, we found isolated without anything else. Okay, known the sun has velocity in the rest of it. Right. It is a proposition of this paper that the velocity is absolute. So yes, I'm going to argue that it has some sort of real velocity. When you add up everything, everything not perfectly round. So if you could analyze the atoms and analyze the protons and the neutrons, anything out of perfect roundness would indicate velocity. And so, yeah, the argument is that the sun has an absolute, when you add up all the little bits, all the spins and all the movements and all the migrations, there's an absolute velocity in a direction. And it is manifest through real imbalances in the energy possessed by the sun, when you add up all of the little bits inside of the sun. Put another way, if all of the imbalances of any material object within the sun resulted in a net balance, okay, so if we add up all the little stuff and it came out balanced, perfectly round orbits, the sun would be absolutely stationary. So I could have bits moving this way, and I could have bits moving that way. I could have stuff rolling this way and rolling that way. But if you add them all up, there was even amounts in every dimension, moving up and down, forward, back, left, right. I would have zero velocity. Most notable about the sun's imbalance, and in turn velocity, is that it's not in any way degraded as the sun moves through the universal kinetic field. So this takes care of the Feynman argument, where there's this argument made that a kinetic gravity or a particle gravity couldn't work because as the Earth moves in its velocity, not its acceleration towards the sun, but its own velocity, it would keep hitting the field, and the field would slow it down because it's going to hit more field in front of it than it's going to hit behind it. You can almost theoretically understand that you can't really, as much stuff as extra you're going to hit this way, you're going to miss hitting this way. And you can almost argue that for every arrow you hit on this side faster, there's going to be one you'll miss because you'll go right past it before it got there. So there's lots of ways to argue around it, but the real technical argument is back to this fundamental principle that the tangential dimension is where the action happens. And so it really doesn't matter. You can go as fast as you want into this field, and you can't make these arrows more effective, because as you go faster, you create less tangential targets. Even though you're hitting more arrows coming at you, there's less targets for them to hit. So it's always proportional. Less targets, more velocity, less targets, more arrows hitting you, but less targets to hit. And that's what makes it ineffective. It doesn't change, it doesn't create any friction, is what we're looking for as an answer. Alright, where was it now? Shit, I forgot. Put another way, all imbalances, no, this is the sun part. As I propose in this paper, the sun is made of little bits moving the speed of light. Okay. As is proposed in this paper, it is understood that the sun is made of little bits moving the speed of light in one of the three real dimensions, forward, back, up, down, left, right. Noticing the obvious, the forward bits seem to be the only ones playing along. So kind of obviously, if I'm moving forward, the only bits that are moving forward are the ones moving forward. You know what I'm saying? And this is always going to be broken down into just averaging out all the ones going at any obscure angle to the 90s. So we're just saying all of those balance out. So just, so yes, there's stuff going at all these other angles, but those other angles all balance out in the end to direction forward or direction back. There's a clear distinction between an arrow going even at one of those tangents and one going the opposite tangent. It's still a difference between forward and back, and it doesn't matter about the amounts because the amounts are going to equal out in the end. But anyway, that's a whole nother subject. Don't want to get lost in that. Alright. Alright, so noticing the obvious, the forward bits seem to be the only ones playing along and going the right way. Unfortunately, they're going the right way about 1,000,000 times too fast. So that's another way of looking at this, right? If I have stuff moving the speed of light, and I have an extra little bit moving the speed of light forward. If it was moving the speed of light forward, it just left the building, right? I mean, it just took off and is now bouncing off the moon right now, and now it's, heading for, like, well, I have to wait 11 minutes to get to Saturn, right? Well, anyway, it's leaving town, and I'm still here. So, quite obviously, what has to happen is it has to be slowed down. That forward arrow can't be just left a forward arrow. It has to do something else besides being a forward arrow for a while, because it's just going too damn fast. So you have to make it do something else, do some other work, and that way it'll slow it down, because then it's doing more stuff in here, and then it won't be shooting off to Saturn. That kind of thing. Seems to be no one playing along. Unfortunately, they're going the wrong way a million times too fast. Fortunately for conservation rules, the up, down, and left, right bits are going pretty much infinitely too slow in the necessary direction. So this is just the argument that my bits going this way and this way aren't moving forward at all. They're going 0 miles per hour in the right direction. So something's got to change, or part of me is going to leave a lot of me behind. Okay, all this stuff in the other 2 dimensions, moving in the other 2 dimensions, isn't going to be part of me anymore if my arrows just take off. So that they have to be dragged along. So this is where we replace those dimensions with this dimension for some period of time, and in doing so compensate, bring those tangent dimensions to the new forward position. Okay. Effectively saying relative forward necessary direction. So there's a reason to believe balance can be achieved. What essentially happens is the bits moving the wrong way are effectively standing still relative to the forward dimensional movement. So obviously I have some bits going the wrong way, and the rest of the bits are going in tangential directions. So all of those are either doing negative things overtly or 0 things, but they're not doing anything positive in terms of playing along with the velocity. They're not doing velocity. Okay. Moving away, effectively standing still relative to forward. Did I read this? So there's reason to believe balance can be achieved. Effectively, let's see. Forward dimensional movement will be replaced for a moment. Let me do this again. I'm somewhere in here. Fortunately for conservation rules, the up, down, left, right are going pretty much infinitely too slow in the necessary direction. So there's reason to believe balance can be achieved. What essentially happens is the bits moving the wrong way, or effectively standing still relative to the forward dimensional dimension, will be replaced for a moment by a bit moving in the forward direction. So again, that forward bit, who has lots of time to use up, is essentially going to be migrated through everything and steal its identity for a little while and move it forward. Now obviously that doesn't happen that way. It happens because these swirls are happening inside of us, and what will happen is this swirl will swirl a little tiny bit faster. It'll cause this swirl to swirl a little tiny bit faster, and then this swirl will swirl a little tiny. So it'll all move through the gear work of the interlocking atomic structure. So when I make these arguments, I'm talking kind of metaphorically that it'll take its place. But it sort of will take its place in the sense that it's the rolling ball. It'll have its way, but it'll have its way in a way you won't see, because it will be the ball moving. That will be the effect of the added spin in one direction. The added spin, always a little push on the top of the wheels. It'll push the top of the wheels a little bit, cause a little extra spin, cause things to move faster. Move, period. Alright. Moving forward the wrong way will be replaced for a moment in a forward direction. For a moment, it is as if the tangential dimensions disappear and then reappear some distance forward in the dimension of the forward velocity. So it's just basically saying that, yeah, the tangential dimensions they're not doing tangent anymore, they do forward for a minute. So they stop doing left-right for a moment, do forward, and then they go back to doing left-right. Let's see. Another way of putting it is to say the bits going too fast forward take some time to jump over to the other dimensions and move those bits forward. The real dynamic is a complex interweaving of spin mechanics, but the end product of a momentary loss of mass in the tangential dimensions, meaning loss of mass, meaning loss of existence doing this, because they end up doing forward, is very practically real and provides the explanation for why the universal field produces no friction to material velocity. So again, the argument is, as I move forward, yes, I hit more stuff coming at me, But as I move forward, my tangential dimensions are tangential less amount of time. They're doing this less, and they're doing straight at the forward direction. And again, clearly needs to be understood. The head-on collision is a nothing. So I can't create friction in a head-on collision. Rule. Momentary loss of mass in the tangential dimensions is very real and provides the explanation for the universal field, no friction and velocity. Simply stated, as a material object gains velocity, the tangential dimensions to the velocity become less material. In other words, as you run into more arrows because you have velocity, the targets get smaller. So less targets to hit, same amount of bullseyes, theoretically. As a point of verification, imagine accelerating a piece of matter to the speed of light. So take a piece of matter full of these little arrows, converting it to the speed of light, moving it to the speed of light, essentially means all of the arrows must go forward. And now all of them are photons. So I essentially convert matter to energy by moving it to the speed of light. If I ever got a piece of matter to go the speed of light, it can't be matter anymore. It can't be doing orbits because all the arrows have to be going the same direction. At such a speed, the matter loses mass in all dimensions but the one it's traveling in. Obviously, the tangential dimension disappears. This up and down disappears. A photon isn't doing up and down. It's not doing left and right. It's doing one thing, forward. And that's what happens to matter. So matter can't have left and right, and it can't have up and down. It can't have orbits anymore. It has to have everything going one way to be moving the speed of light. As a point of verification, imagine accelerating a piece of matter at the speed of light. I already read that, right? At such speed, the matter loses mass in all dimensions but the one it's traveling in, like a beam of light. A side effect of this mass redistribution is the phenomenon referred to as time dilation, which is really the slowing down of atomic metabolism in deference to the new activity of velocity. So I have a paper on that, but you can sort of get it, right? If I'm gaining velocity through acceleration, by going faster and faster and faster, more and more my arrows are moving in one direction, then obviously I'm losing whatever other activity I was doing. So whatever metabolism, whatever orbits my systems had, those orbits are now really slowed down because they're doing an awful lot of something else most of the time. So any time taken to do velocity will be taken away from what the matter was previously doing. It can't give away time. It just can't create time. So if it has to do stage left, then it can't do the production it was doing before it had to move stage left. It can't dance as fast if I have to dance and run at the same time. Okay. Alright, so now we're going to try to get back to it again. Okay, now, back to the sun and earth and gravity. This time, let's remove everything else from the material universe to avoid further distraction. So we have a sun floating in space, and now add the earth approaching with a velocity. Now let's describe the field and material dynamics. Okay, so we have the sun, and the earth is somewhere, and it's coming towards the sun vaguely. And is going to get captured in an orbit in the sun. So that's the idea of it. On the material side, so now talking about what's happening to the pieces of matter, start with two massive bodies in equilibrium with the fields around them. Equilibrium just means that the Earth is moving, it's got a real good velocity, but as I just pointed out, it's hitting more arrows it's coming into, but it's also losing its tangential dimensions, so there's fewer targets, so it's just passing as if it's in balance. Its velocity, it's balanced, and it's perpetual. That's why velocity doesn't degrade. So it just has a, it's not being accelerated as it's heading for the sun. It just has a velocity. There's a difference between acceleration. Acceleration is gaining arrows or replacing tangential dimension, and velocity is I've already replaced it. This is how much, this is how much tangential dimension I have, and yeah, I'm moving. And so they're two different things. On the material side, start with two massive bodies of equal luminance as they aren't being aggressively changed by the field around them. But even this limited starting state does involve some action, as both the material bodies are subtly vibrating in random bits of acceleration in random directions. So you sort of have to understand, as the field's hitting me again, it's sometimes little random bits. There's a little extra coming this way, and so I move a little that way, and then there's an extra bit comes, so the flip of the tail, you know, heads, tails. Sometimes I get 3 heads on one side, then I get 3 tails the other side, blah, blah. It evens out in the end. But I am jostled by it all the time. Brownian motion. But even this limited starting state does involve as a material acceleration and random. The universal field applies constant pressure over time, but the random minute moment to minute moment, but not, yes, not important, it is there, but not random minute moment to minute moment. So overall, there'll be a certain, you know, the heads and tails will even out, but at any one moment, there could be more heads than tails. So in one of these minute moments, the sun experiences a bit more force from the field on its side facing away from the earth. So behind the sun, as I'm coming towards it, okay, there's just a random little extra bit. Well, I guess it should be the other way around. There's a little random void, but it really doesn't matter. Let's see. Okay, this small imbalance causes the sun to absorb a few more force arrows moving in the direction of the earth. So the sun has a little bolt of acceleration towards the earth, and that little bolt of acceleration comes from the fact that it's now absorbed the extra arrows it felt it had coming at it. So it got a little less arrows coming in its face. It then absorbed the extra arrows coming from the back and moved a little bit forward. But that movement causes it to now absorb those arrows, so now I have a little bit less coming at me, the earth. That's what's going to be stated here anyway. Towards the earth, and momentarily prevents those force arrows from continuing their speed of light journey to the earth. So when the sun accelerates towards me, there was stuff coming at me the speed of light, and now that stuff isn't coming at me at the speed of light. Now the sun is moving at me 2 feet an hour or something, you know, or one millimeter a year. You know, some tiny little bit of acceleration, but it's there. All right. And momentarily prevents those force arrows. Okay, there's when this slight reduction in force reaches the earth. So at the speed of light, the reduction reaches the earth. The earth is put in imbalance, and it responds by absorbing more force arrows heading for the sun. So when I feel, so not I, but the matter, less hits it from this side, that means it has more from the other side coming back, so it absorbs some of those. Those hit targets, the tangents, those are absorbed, and now I'm giving off a shadow. Now I'm going to send a low pressure, an absence of arrows, to the sun. Okay, when a slight reduction reaches the absorbing and heading for the sun, towards the sun. Okay, so when this slight reduction reaches the earth is put in imbalance, and it responds by absorbing more of the force heading for the sun, and consequently accelerates towards the sun. So it's just a battle of acceleration now. Once the sun accelerates towards me, I'll accelerate a little extra towards it, and then it'll accelerate a little extra towards me, and then I'll accelerate a little extra towards it. So we're just going to have a feedback loop that will induce a maximum amount of attraction based on the density of the field and my mass. Okay, the action creates a kind of infinite feedback loop until induced acceleration reaches its mass potential limits. So it takes a certain amount of each little atom, it's a nuclear thing that's being absorbed, this gravity. It's absorbed by your nuclear bits. The quanta are doing the work. But it's about how much density you have. You have to have a density, not really mass. A density, mass density, to have targets to hit. So more targets, then more force you're capable of blocking. I'm only capable of blocking so much force because I only have a certain thin density. But if I could make myself 50 feet long at this bulk, that length would have more gravity than this going this side. So I'd obviously be creating less gravity going through me the thin way than I would be the long way. It's kind of another giveaway, you know, the bent space argument being kind of fallacious. It's the idea if I make things non-round, bent space doesn't accurately describe the circumstance. You're not going to be able to put rectangles in your bent space and have them properly reflect what they're gravitationally producing. Alright, so it momentarily prevents the force arrows from continuing their speed of light journey to the Earth, absorbing more force arrows of the Sun. As it accelerates towards the Sun. This action-reaction creates a kind of infinite feedback loop until induced acceleration reaches its mass potential limits. Okay. Of course, there are lots of subtle mores to the story. For example, as the Earth would be moved towards an orbital position with the Sun, its acceleration would be increasing its velocity. So as I'm moving towards the Sun, my velocity will increase because my acceleration will keep getting added on to my current velocity because they're both almost the same vector, right? I'm heading generally towards the Sun, and so all is going to be changed. I'm just doing a subtle change in my velocity vector with my added acceleration. So now most of my acceleration will actually cause higher velocity than directional deflection, wherein once I'm in orbit, then the deflection is huge in terms of how much of my velocity is being killed by the other dimensional velocity pushing me towards the Sun. And so now all of the extra velocity is used up by the acceleration by creating that angle. If that angle was smaller, then I would increase my speed. So you have to be heading towards the Sun for your speed to be increased. And as soon as you're not heading for the Sun, some other direction, then your acceleration towards the Sun will not add to your velocity. Obviously, if you're moving away from the Sun, then it'll degrade your velocity. Your velocity will absolutely reduce, and you might even get pulled back into the Sun because you won't have enough escape velocity. Alright, of course there are lots of subtle blah blah blah. Increasing velocity, the vector direction of the velocity would be consolidated in one forward dimensional direction. Okay, so this is probably alright. Of course, this, as the Earth moves towards the orbital position of the Sun, its acceleration will be increasing its velocity, and the vector direction of the velocity would be consolidated into one forward dimensional direction. So as these forward arrows you have extra of are doing this business of breaking, dragging the tangent dimensions, as they're doing that, if there is any velocity in one of these tangent dimensions, they're going to combine the two things, and again, like a gyroscope, they're just going to reorient what forward means. So where forward is this way, they'll just change forward to that way, and my Y and Z axes will be reoriented technically. It's a technical thing. I don't know if it's a real thing. It's the wrong way to put it. It's a real thing. Okay, I'm just saying I don't think you have a real gyroscope. It just means that everything kind of functions with the consistency of a gyroscopic dimension. So all of your spins will turn to rematch their old balance. Alright. Increasing its velocity in the vector direction of velocity would be consolidated in forward direction. Stated as a rule, an element of matter will not hold velocities in two separate dimensions. So you can't hold velocities in two separate dimensions as matter. Matter can only have velocity in one of the dimensions. It has to kind of obey this rule, and so it will consolidate any velocities in different directions into a single vector of direction and velocity, and will continually rebalance separate dimensional velocities into the new net velocity with adjusted dimensional orientation, which is adjusted dimensional orientation is just this gyroscope kind of thing. It'll readjust the XYZ axes. Stated more simply, the direction of the Earth's original velocity will be gradually, and once in orbit, continually bent toward the Sun. So it's just saying that all the acceleration you gain from the Sun will end up being added to your pre-existing velocity, and there'll be a new vector created that will be called the Earth's velocity. Alright, got there, didn't it? So I think that's enough. You might have to do 4 parts, so we'll see. So yeah. Till the next time and such. But this was important in terms of this debunks the Feynman argument that you're going to have friction with the field if there's a field. And so these are always arguments used for ether, against ether arguments. You know, people talk about ether because then you have to argue, well, why wouldn't the ether cause friction? And the reason why is if you make it kinetic, you can understand that in kinetic interactions, the head-on collision is the least visible if it were to really be happening in front. If you didn't have those balls tied to strings, you really wouldn't know what happened when two things crashed into each other. You wouldn't be able to see the difference between, if there wasn't a sound or something else, it would just look like they missed each other. Alright, so, till next time and such, and so forth and whatnot.